Welcome students to the second module of chapter number 12, Carbon and Important Element. In this module, we will learn fullerene, its properties and uses. Also, we will learn non-crystalline allotropes of carbon. In that, we will study coal, charcoal and coke along with its properties and uses. Then we'll see hydrocarbon. In that, we will discuss two types of hydrocarbons, that is saturated and unsaturated hydrocarbon, in detail. Fullerene, an allotrope of carbon, is rarely found in nature. It is found in soot and also in interstellar space. The first example of fullerene is Buckminster fullerene C60. This allotrope of carbon is named fullerene after the architect Richard Buckminster Fuller because the structure of carbon 60 resembles the structure of the geodesic dome that he has designed. Carbon C60, C70, C76, C82 and C86 are the other examples of fullerene. Let us look at some important properties of fullerene. Molecules of fullerenes are found in the form of buckyballs and bucky tubes. Buckyballs means a hollow spherical molecule composed of a large number of carbon atoms. There are about 30 to 900 carbon atoms in one molecule of a fullerene. A fullerene is an allotrope of carbon whose molecule consists of carbon atoms connected by single and double bonds so as to form a closed or partially closed mesh with fused ring of 5 to 7 atoms. The molecule may be a hollow sphere, tube, or many other shapes and sizes. Fullerene is soluble in organic solvents such as carbon disulfide, chlorobenzene, etc. to give a deep purple color solution. Let us discuss various uses of fullerene. Fullerene is used as insulator. Presence of free electrons in fullerene contributes to the conducting electricity. Though the free electrons are present in the molecule of fullerene, they are held by weak forces. Hence, their movement is inhibited. As a result, fullerene doesn't conduct electricity. At a certain temperature, fullerene exhibits superconductivity. When pressure is applied to the fullerene, the intermolecular distance gets shortened and the electrons start moving and the fullerene is get transformed into a metal and exhibits superconductivity. Fullerenes are also used as a catalyst in water purification process as it has ability to oxidize organic contaminants present in the water, and also it helps to inactivate microbes in the dirty water. Now let us discuss the non-crystalline allotropes of carbon, which are also called as amorphous allotropes of carbon. In these non-crystalline allotropes of carbon, the arrangement of carbon atoms is not regular. There are three non-crystalline allotropes of carbon, namely coal, charcoal, and coke. Now, let us know more about these non-crystalline allotropes of carbon. Let us discuss the first one of the non-crystalline allotropes of carbon, that is coal. Coal is a fossil fuel. It contains carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. It occurs in the solid state and it is of four types. Formation of peat is the first step in the formation of coal. It contains a high proportion of water and about 60% of carbon. Therefore, not much heat can be obtained from peat. Peat was transformed into lignite due to increased pressure and temperature inside the earth. It contains 60 to 70% of carbon. Lignite formation is the second step in the formation of coal. Bituminous coal was formed as the third step of formation of coal, and it contains 70 to 90% of carbon. Anthracite is known as the pure form of coal. This coal is hard and contains about 95% of carbon. Charcoal is produced by the incomplete combustion of plant or animal products. The major use of charcoal is for outdoor cooking. Animal charcoal is produced from bones or horns from animals. Bone charcoal is a form of charcoal produced by heating bone in the presence of a limited amount of air. It is used in removing colored impurities from liquids. On the other hand, the charcoal made from plants is formed by combustion of wood in an insufficient supply of air. Let us discuss various uses of coal. Coal is used for producing heat for households and also for firing industrial boilers and generators to manufacture various products. Coal supports numerous non-energy industries including steel and cement production. Coal is also used to produce electricity by burning coal in a boiler to produce steam. The steam produced under tremendous pressure flows into turbine, which spins the generator to create electricity. The steam is then cooled, condensed back into water and returned to the boiler to start the process again. Coal is one of the most useful fossil fuels. It has many applications. It can also be processed industrially in order to obtain products like coke, coal gas, and tar. These byproducts are beneficial to us also. Coke is a highly carbon content product obtained from coal. The amount of carbon contained in the coke is so high that it is said to be an almost pure form of carbon. The most common use of coke is as a fuel for stoves and furnaces. Coal tar is a thick dark liquid which is a byproduct of the production of coke and coal gas from coal. It has both medical and industrial uses. Coal tar is widely used to manufacture paints, perfumes, synthetic dyes, etc. Coal gas is also obtained as a byproduct while producing coke. It is a highly inflammable gas as the main component of it is methane. It is more commonly used to provide heat for domestic and industrial purpose. Coke is one of the important byproducts obtained from coal. The pure coal that remains when coal gas has been taken away from coal is called as coke. Mainly, coke is used as good domestic fuel. Coke is good reducing agent especially at higher temperatures because it is a non-metal and it combines with oxygen and forms its gaseous non-metallic oxides. Coke is used in production of water gas and producer gas. Water gas is a mixture of carbon monoxide and hydrogen which is produced by passing steam over red hot coke. It can be used to power internal combustion engines, gas turbines, etc. Carbon is the most common and important constituents of most of the substance around us. Along with carbon, the element hydrogen is also included in most of the organic compounds, and the compounds formed from only carbon and hydrogen are called basic organic compounds, and These are also called hydrocarbons. The electronic configuration of carbon is 2,4. Therefore, the valency of carbon is 4. A carbon atom can form 4 covalent bonds with other carbon atoms or atoms of different elements. When a carbon atom shares one electron with 4 hydrogen atoms, it forms CH bond and a compound methane gets formed. A carbon atom exhibits a characteristic property. It can form a chain of carbon atoms by forming covalent bonds with other carbon atoms. The hydrocarbons having only single bonds between carbon atoms are called saturated hydrocarbons. Let us discuss some examples. For example, ethane. The formula is C2H6. In this hydrocarbon ethane, there are 2 carbon atoms and you can see there is a single covalent bond between these 2 carbon atoms. One more example is propane. Formula is C3H8. In propane, in this hydrocarbon, there are 3 carbon atoms and there is a single covalent bond between 2 carbon atoms. So such hydrocarbons are called as saturated hydrocarbons. Some hydrocarbons have a multiple bond between 2 carbon atoms. A multiple bond can be a double bond or a triple bond. Hydrocarbons having at least one multiple bond are called unsaturated hydrocarbons. For example, ethene, chemical formula is C2H4. Here you can see there are 2 carbon atoms in this hydrocarbon and there is a double bond between 2 carbon atoms. Next example is ethyne, chemical formula C2H2. Now here there are 3 bonds, that means there is a triple bond between these 2 carbon atoms. Such hydrocarbons which contain at least one multiple bond, it can be double bond or it can be triple bond, are called as unsaturated hydrocarbons.